Hello, Accelerated Math 6-7 students. We are now going to work on Module 2, Lesson 5 video. And Module 2, Lesson 5 video is called The Relationship Between Visual Fraction Models and Equations. And we can find that on page 47 of my comp book. So I'm going to turn there now. And here we go. So the relationship between visual fraction models and equations. Basically what we're going to try to do is we're going to try to look at the visual models and help us write what we see into an equation. The goal for today we will use models to prove that equations are true. The question that I want you to be thinking about is, how are division and multiplication related? Very interesting question. Things to know for today is division is the opposite operation of multiplication. So basically the way that you could think about it is division undoes multiplication, or multiplication undoes division. So if you're trying to undo something, you do the opposite operation, and division is the opposite operation of multiplication. So dividing by a number is the same as multiplying by the reciprocal of the number. And I'm not sure if you're familiar with the term reciprocal, but reciprocal is used when you are taking any number, you turn it into a fraction, and then you flip it so that the denominator becomes the numerator and the numerator becomes the denominator. And so that's called multiplying by the reciprocal. So this little chart is going to come in really handy, and it's going to help you. If a problem asks you to divide by 2, dividing by 2 is the same as multiplying by 1/2. And the way that we're going to see and prove this is, if you're dividing something by 2, let's take 4. 4 divided by 2. Everyone in our class hopefully knows what 4 divided by 2 is. Boys and girls, what is 4 divided by 2? If you said 2, you are correct. So if we're proving whether this works or not, then multiplying by 1/2 should give us the same answer. So you take 4 again, and this time we're going to multiply it by 1/2. Well, in order to do that, we have to take this and make it a fraction over 1, because 4 divided by 1 is still 4, so we didn't change the value. We multiply it straight across, so 4 times 1 is 4, 1 times 2 is 2, and then 4 divided by 2 is 2. So we came up with the exact same answer. So right here we have proven that when you divide something by 2, it's the same as multiplying by 1/2. So what if I ask you if you divide by 3? If you're dividing by 3, what is that the same as? Dividing by 3 is the same as multiplying by 1/3. So I would like you to fill in the next one right now. Dividing by 4 is the same as, everybody fill that in. We'll check it on the board in the morning. And then dividing by 5 is the same as, okay, now we have to see if you're paying attention, because the next one says, what if we divide by 1/2? So let's look. We have 5 divided by 1/2, okay? And in order to solve that one, we have to find the common denominator. So we have 5 over 1 divided by 1/2. So we find the common denominator of 2 divided by 2. So get to 1 to 2, you multiply it by 2. What you do to one side, you have to do to the other. So that becomes 10/2, sorry. 5 times 2 is 10. And then you divide by 1/2. And so we divide straight across, and we get 2 divided by 2 is 1. 10 divided by 1 is 10. So the answer is 10. So now let's see if this works, because originally we said if it says divide by 1/2, it should be equal to multiply by 2. Well, if we take 5 and we take that times 2, what do we get, everybody? 10. Do you see how we just proved that it works? Okay, so dividing by 1/2 is the same as multiplying by 2. So what would dividing by 1/3 be? It's the same as multiplying by 3. Dividing by 1/4 is the same as, you fill it in. Dividing by 1/5 is the same as, you fill it in. So hopefully this chart right here is going to be really helpful to you to remember that dividing a number is the same as multiplying it by the reciprocal. The reciprocal of 1/2 is 2. The reciprocal of 1/3 is 3. The reciprocal of 1/4 is 4. And the reciprocal of 1/5 is 5. so you can see that hopefully by us just showing that picture, we proved it to you. Okay? So let's take a look on the back of what we're doing, and we're going to try it with proving. So we have 3/4 divided by 2/5. So again, we do a little bit of math to help us figure it out. We have to find the common denominator, so I chose 20. How did you get from 4 to 20? You multiplied by 5, so 3 times 5 is 15. How did you get to 20 from 5? You multiplied by 4, so 2 times 4 is 8. Divide straight across. 20 divided by 20 is 1. 15 divided by 8 is 15/8, so the answer is 15/8. Okay? So then, if we choose to use the picture, we have 8/20 right here, right? So we have 15/20 up here. That's the total. And then we divide out 8 of those 20ths. How much do we have left? We have 1, 2, 3, 4, 5, 6, 7. And we get 7/8 out of that answer. So 15/8 would be 7/8 are the remainder. Okay? So now, right here, you're saying this. So 3/4 divided by 2/5 is the same as multiplying by the reciprocal. Let's see what happens. 3/4 times the reciprocal of 2/5 is 5/2. Multiply straight across and you get 15/8. And then when you take those 8/20 out, you're left with 7/20 as the answer, so you have 7/8. Okay? So I want you to try this next one by yourself. Everybody take a look at it for me. So the problem that we have up here is 3/5 divided by 1/4. So first you're going to find the common denominator, and then you're going to get the answer. Then I want you to build a model of what you did, and then I want you to try it by multiplying by the reciprocal and see if this answer matches this answer. So this is the one we're going to be checking in the board when you get to school. Okay? All right, so let's go back to the beginning. Our goal for today is we will use models to prove that equations are true, and we did that. How are division and multiplication related? I think you kind of have the answer right here. So try that last one by yourself. Hopefully it's not very scary or hard, and we'll talk about it and practice it some more in the class tomorrow. All right, my dears, that is it. Have a great evening, and I'll see you tomorrow. Bye.